We are live. Hello, everybody. Welcome to the October 7th, 2021 edition of Groundwater Talk Live. I think we got a pretty decent show for you today. We're going to talk about well management from start to finish. We're going to give you an overview because obviously any of the topics we talk about are going to be in-depth, long topics in and of themselves. So we're going to give you an overview, but the premise really is we're dealing with water wells are an asset, and they're a valuable asset. Municipal wells can run up to $1.5 million, $2 million to install a well and get it up and operational. So they are a valuable asset, and we want them to last as long as possible and really have the lowest cost over their lifespan. So really, you need to have a program that manages wells from beginning to end, and that's basically what we're going to talk about today. Is give you an overview on that. So let's dive in here. We have a process we call systematic well management, but really what it comes down to, this is asset management for water supply wells. And we're really focused on the well here. Wells are fairly unique in a water system because they're below ground. You can't always see what's going on, and you can say that that's true of the distribution pipelines and everything else, but there's a lot of chemical issues and a lot of things that happen below ground. So it's really important to get it right from the beginning to the end. And the way I look at it is a well is an asset, just like your car is an asset. You'd change the oil, you change the transmission fluid at the designated intervals, and that's really what you need to do with the well. So starting from the very beginning, this is a 10-step process. Other people may break it out a little bit differently. Probably we spend most of our time kind of here in the middle, and so we'll dwell on that a little bit. Once you get through stage 4 here of getting your well up and operational, we got the little clock here on our flow chart that shows there's going to be some time that goes on, but all wells are going to start plugging up. They're going to have some issues with time. You run these things for 40 years, 50 years, they're going to require some maintenance. And so we usually spend a lot of time here in stages 5 through 8. And really look at diving in and seeing what the problem is with wells. So we come in at the beginning on a lot of cases. As a consultant, I come in at the beginning on the design and the location, but a lot of the stuff that I get involved in involves these middle cases where wells are starting to have some problems. So let's break this down step by step. So first off, let's look at well location. I mean, this is where it all begins. And the important thing to remember here, and I got plenty of stories about this, is the best location is not always the most convenient. So where you find water is not always the most convenient location. It's just the way it is, and that's especially true when we get to alluvial versus bedrock aquifers, fractured rock aquifers, people call them. It's really important to get it right in a fractured rock aquifer because we're looking at fracture zones, fault zones, especially intersections, and getting those nailed down is really key to getting a productive well. Alluvial aquifers tend to be a lot more forgiving, and so you can step over 100 feet or so and not really have any issues. With a fractured rock aquifer, you may step over 10 feet, and that's the difference between a productive well and a well that really doesn't produce all that well. So it's important. There's a lot of things that go into the location part. We tend to use a weighting system, so we prioritize locations. So we'll go through as we're looking at locating a well and evaluate locations for that well based on a priority system. And then we give different factors such as environmental issues, well interference, property lines, access, proximity to existing infrastructure. Those are all things that get prioritized and get weighting on our system. And then we come through and we look at maybe 4 or 5 locations, prioritize those, and so the one that comes out on top with our weighting system, that's the one we'll usually go out and drill a test well first. You got some backups there. I usually like to have at least 2 or 3 locations in case one doesn't pan out for some reason, you didn't quite get it right. But with a prioritized ranking system and going out and systematically evaluating those locations, that's really what's going to get you in the right territory to get a productive well. So you got to do a little bit of background. There's a lot of tools, and like I say, for every one of these steps here, we have some other classes we teach that dive into these things in great detail. So that's really what we're looking at here. So number 2 is well design. And what we're gonna do is generally the system we use is we're gonna go out and drill a pilot boring first. So we're gonna take our prioritized location. We're gonna go out and drill a pilot boring first. We're gonna log that geologically, and I always recommend that you do a geologic log in addition to the well driller's log. It's really key because you get drillers not geologists aren't drillers, so you really need both on the job, and so it's important to have a geologic log to help define your productive zones and how you're going to design this well up. So we'll also run the E-log and then do zone testing as appropriate. I like to do the zone testing using a long screen and go in with the electromagnetic flow meter and look at the flow profile and those things. And it's the old system of going in and doing zone testing by building wells and then building another well inside it and pulling everything out is time consuming. It's expensive. It's much easier to go in and do some dynamic flow profiling with a long PVC screen and electromagnetic flow meter, or there's some other methods for dye trace method for doing that out there as well. So and really have as much information as possible so you can feed that into the design and get things right. So we're also going to do a sieve test so we can properly size our screen and gravel pack. So that's important, especially in an alluvial well. That we're going to want to be able to make sure we maximize the flow to the well while keeping out all the fines and the sand. So that's an important part of the process. Sometimes that gets short shrift, but it's something we got to look at. You want to know what your water quality is. Running a Langolier saturation index or aggressive index, letting you know how corrosive your water is, because that can feed into the design as well. Are we going to use stainless steel? Are we going to use some other type of steel, mild steel, or all the grades in between? And so if you have very corrosive water, then you're probably going to be looking at stainless steel. I think most production wells these days, or the larger municipal wells, are pretty much all stainless steel. But we get into some of these smaller districts, and sometimes they're looking at PVC and those types of things. And PVC isn't going to be affected, of course, but I don't think it lasts as long as metal. So, but we can argue about that all day too. Well efficiency is going to come into play. Entrance velocity, you're going to want to design your well so that you don't have water coming in too fast, which seems a little counterintuitive, but water that comes in too fast is almost as bad as water that doesn't come in at all, because you can create turbulent flow. It's going to make your pumps work harder and things like that. So you can design the well around your entrance velocity as well. So a lot of different factors here. Some I'm not diving into all the little nitty-gritty details here, but one of the things we're going to want to do at this point in between the design and the construction phase is come up with what we call the optimal well plan, performance plan, optimal well performance plan. And That's going to be our guideline for maintaining that well throughout its life. And we're gonna look here farther. You look at step 8, and we go back and we adjust that. And so we're going to adjust that as the well ages over time. It may develop some issues that we didn't have at the beginning or couldn't anticipate. So you're going to tweak that over time. But we want our optimal well performance plan to be in place, because that's going to be our, maybe the little booklet that they have in the office that tells them, what kind of maintenance they need to do, what, the sampling and anything they need to do to maintain that well. It's just like, you're going to go out and change your oil every 3,000 miles or whatever it is on cars these days. And that's going to be that type of thing. You get an owner's manual with your car. You're going to develop your own owner's manual, or the OWPP, with your well. So that's your owner's guide. We don't see that actually a lot out there, but it's something that I really like to see, because you're going to have people come and go, especially for smaller water districts. Like what I work with, is having an owner's manual for that well is really what these people need, because a lot of these people running the smaller water districts aren't necessarily technical people. They're not geologists, they're not engineers, and so having this guidance that's written by somebody that understands the well, that originally designed and built the well, is really going to go a long ways towards maintaining that well. So I think it's good to have an owner's manual for that well that people can reference and guide them as they go along. And because groundwater can be a little bit dynamic, things can change over time, is you are going to have to adjust that, and we'll talk about that a little bit later. Okay, so now we get into construction, and we have some standards out there. Most states have construction standards you need to adhere to. And there are another organizational standards that are published out there. The one I really like that most people probably use is the American Water Works Association A100 standard. That's updated every 4 to 5 years, I believe. So I don't know. The last one I have is from A-115. There may be a more recent one than that I don't have, but at that time, I think that's what we're dealing with here. So if it hasn't been updated in the last year or so, it's due to be updated. And the state standards, like I mentioned, California, Tennessee, where I work a lot, both have state standards that you can follow. California's, I know, are a little out of date, so they're working on updating those. So once again, we need to go back to our design and construction really work together, taking the geology and the e-logs into account when we build those wells, and take advantage of that information we developed during the pilot boring and all that when we build our well. One of the things that I will point out here, and like I say, we do more detailed classes on all these, but paying special attention to well seals. It's a common point of well failure, and most standards from the states will have, for instance, California has a 50-foot minimum seal on a municipal water supply well. Tennessee, I believe, it's 21 feet or grounded into bedrock. So whatever the state standard is, you can usually consider that to be the minimum. And a lot of problems we see, especially with things like nitrates in wells, originate from poor well seals or not taking the geology into account. I can say that as a geologist, because we see well seals that are just slapped in there, a 50-foot seal with no regard to the geology, and then you have a surface water infiltration, which is really what nitrates are, is shallow groundwater that is impacting them, that's going into the well, and it hasn't been properly sealed. So usually when I deal with a nitrate issue, the first thing I look at is well construction and check the geology versus the seals. And I will say probably in 90% of the cases, that's going to be the problem right there is the nitrates, and you have an inadequate well seal. So it's something that really needs to be taken care of up front. Of course, you want to spend enough money, you can do anything, but it's hard to fix a well seal after it's already in. There's ways to do it, but it's going to be more expensive. So maybe we want to try to get it right in the first place. Another real common area of well failure, I guess I can call it well failure, or maybe just underperformance, is the well development process. And this is a really important part of the well construction, or post construction actually. You're cleaning out all the mud, and so you're doing the development. At the same time you're doing construction, and you're going to finish development once the well has been constructed. But you're cleaning out all the mud, you're cleaning out all the sediment, and you're basically developing that pathway, a pretty clear pathway for groundwater to flow into the well. So this will affect well efficiency. It'll affect your production capacity, and we see a lot of wells where development was not done completely, and that's really something we look at as well. And when we're involved in the process of building a well development is really something we pay a lot of attention to. It's usually going to be underbid. The driller is not going to bid enough time for well development. You can pretty much count on that. And I always tell my clients that if you're going to get a change order, it's going to be for well development, because you want to have that done right, or you're going to have endless problems. And we see it all the time. And a lot of times you can track it right back to poor well development. They just did not give it enough time. So the way we do that is when we write into the contract for the driller, we're going to set goals for sand production. We're going to set goals for turbidity. We're going to set goals for specific capacity. Some people will look at well efficiency goals as well, but we want to have some numeric goals that the driller has to meet. That way, there's no argument when development is done in the well. So that's really important to make sure that well development gets done. Otherwise, if it's kind of wishy-washy in the contract, then there's going to be some argument as to whether it's done, and you don't have anything that's enforceable. So best off to write it right into the contract right up front. All right. So now we got our well. It's been out there producing for a number of years, and maybe we're starting to see some production capacity loss, and so we want to know what's going on with that well. And we have what we call the well health check process, and that's really just a snapshot of the current conditions of the well, or the current health of the well, if you will. So it's like going to your doctor for a checkup. We want to see what's going on. Is it healthy? If it's not performing as well, are we getting any plugging? What are the signs of that? And so there's a number of things you want to do at this point. And so we're going to want to look at basically four areas. We're going to look at physical parameters, stuff like the efficiency of the well. We're going to look at specific capacity and some of those physical parameters that allow us to see declining production in the well. Specific capacity is really a good one under the physical parameters. It's easy to measure. You're going to be doing it anyway, so you got those numbers right at your hand. So tracking that over time is really going to be a great indicator of lost production capacity in the well. And mark my words, all wells experience loss of production capacity over time. It just happens. It's part of the natural process. How fast it happens is going to be regulated by the number of variables out there. But all wells are going to lose production capacity. You're gonna want to look at those wells when they start to decline. So even if you're only tracking specific capacity, you start losing 10 to 15% of your specific capacity, then maybe it's time to start looking at doing a little bit more detailed investigation and go to the well health check process. We also look at a number of chemical parameters. So these are a full range of things, looking at at the oxidation reduction potential, for instance. If we got any contaminants in the well, we're going to look at any indicators that could indicate we got mineral incrustations going on, alkalinity, hardness, those types of things, iron, and we tend to speciate the iron between iron 2 and 3, manganese. These are all things that can cause mineral incrustations. And there's a long list of chemical parameters that I don't have time to get into here, but they all have specific things we're looking at to determine the health of that well. Biological parameters, biofouling probably accounts for 80% or more of well plugging cases out there is going to have some biological component to it. So it's important to understand what your biological parameters are, and also to kind of break things out. We want to look at the standard method for looking at bacteria in a well, and by the way, bacteria are always going to be there in the well. You're never going to get rid of all the bacteria in the well. So it's how many bacteria are there. So there are certain levels that it's going to start to be unhealthy. You're going to want to track those trends. So in the past, we've really looked at heterotrophic plate counts as our major method. The problem with that is they only look at aerobic bacteria. And anaerobic bacteria tend to be are bad actors in the well. A lot of pathogens are anaerobic, so it's important to look at all bacteria. So we generally look at using adenosine triphosphate or ATP analysis to look at total bacteria count in the well. If you're looking at things like iron-related bacteria, sulfur-reducing bacteria, slime formers, there are specific biological activity reaction tests that are cheap and easy to do, and we actually recommend, if you're prone to biofouling, to run those at least once a year. I mean, the tests, if you buy them, they're about $25 a piece. They're specific for a specific group of bacteria. So there's a BART test for iron-related bacteria, BART test for reducing bacteria. So they're specific to that, but you can run a range of those, and it's going to be relatively inexpensive. And then we look at operational parameter factors. Do we have any well videos? And we always recommend doing well videos. So that's part of a well health check. Get some eyes down the well. If you pull the pump, run a well video and have some of those on hand, because you can compare video to video. I can't tell you how many hours I spend looking at well videos, but it's really and important to get eyes down there in the well. So we look at any rehab history, we look at maintenance history, we look at the regular analytical, the water quality data that's taken for EPA and state reporting purposes, and we pull all that together, and then we'll come up with a series of recommendations based on that. It's relatively inexpensive compared to the grand scheme of things to do a well health check, to run the labs and do the microbiological analysis, and to get some recommendations based on that. So it's usually that's going to be sufficient to be able to come up with some recommendations for doing any well rehabilitation or any maintenance on that well, and that should be the result of the well health check is really a set of recommendations on what are the indications, what do they tell us, and what are our recommendations for what we can do to improve the production capacity of that well. It's usually going to be some type of well rehabilitation, and so we can dial that in with our well health check. In some cases, we may need to go to more specific diagnostics. So we may have some problems in the well that we have an aging well. And so sometimes if you're diving into things like we got specific contaminants in a well, nitrates, arsenic, radionuclides, and we want to look at maybe modifying our well where we can reduce those concentrations coming into the well and get our water down below the MCLs, the appropriate MCLs for those contaminants. Then sometimes some well profiling applicable at this stage. If we have seal issues, there are tools we can go in there and measure the void space behind the casing to look at cement bond logs, for instance, is a way to look at any void spaces. So if we have failing well seals, which can lead to problems as well, and surface water infiltration into the well, then that's really a specific tool for that as well. Casing issues. There is a tool out there that allows you to measure the thickness of the casing, and so we can compare that to the original thickness to see if corrosion is causing any weaknesses in that casing. So if we've had a well that's been around a while, and for instance it's a mild steel well and it's been around for 40 or 50 years, then doing the casing integrity tool may be applicable, because even if you don't have holes or areas where it's actually corroding through, you can look at where the casing wall is getting thin and a probable point of failure. So and that's something that it's a little bit more specialized technique. You're going to have to pull your pump, obviously, and do that, but it can give you a heads up on any points of failure and any repairs that may be needed. So certainly if you have corrosion going on in your well, you can go in and this will help you dial in where you may need to do patches in the well and any swedging to fix any problems. So not all wells are going to require the more specific diagnostics, which tend to get a little more pricey than just doing the well health check. And a lot of times we can get by just fine with the well health check. It's just like if you, going back to my car analogy, and I use this a lot. So if you change the oil regularly on your car, which is what the well health check is, now you're doing the appropriate maintenance, then you should know what's coming and maybe not have to do these more specific diagnostics. If a well's been sitting there for 50 years as a mild steel well, it's in a corrosive environment, then you may need to do more a deeper dive, and it's going to end up being a little bit more expensive. But that's not really going to be necessary for all wells. So it's going to you run the well health check first, see if any further diagnostics might be indicated, and you go from there on that. So next step up is well rehabilitation, and a well that over its lifespan is going to last the longest and operate at the lowest possible cost is going to have regular well rehabilitation. And what the schedule is really going to be indicated by the well health check. So we should get, once we've run a few well health checks and done rehabilitation a few times, we should really have a pretty good idea of what our schedule is and go from there. So it's something that you're going to build in, and that's when I talk about our next step is tweaking the optimal well performance plan. Is you're going to get a sense of how often you need to do well rehabilitation. Now, if things change in the well, that's where our well health check comes in, and that's going to tell us part of our recommendations in the well health check is going to tell us how soon we really need to do well rehabilitation. Are we in the red zone and we need to do rehabilitation right away by all the indications? Or can we wait a number of months and get it taken care of? But that's really these steps 5, 6, and 7 all operate together to kind of give you the best plan for your well and doing well rehabilitation at the optimal times. Well rehabilitation can be fairly expensive, so you don't want to do it too soon, but you don't want to do it too late. If you wait too long, then it's really hard to go back and recover all that lost production capacity in your well. So well rehabilitation to keep the cost down to the minimum on the well rehabilitation, yet still do it right, is really a timing issue. And so running the well health check is going to allow you to fine tune that timing and allow you to plan and budget. And for a lot of small districts, well, heck, any water district, having things budgeted out is really going to be your best plan. You don't want to all of a sudden have a well stop working. You don't have the budget to do well rehabilitation, so you have to go out there and do an emergency rate increase, which all of the customers really love. But if you've done steps 5 and 6 appropriately, you should be able to dial in that well rehabilitation and properly plan and budget for it. And I think that's really important. So, and that really feeds back to the whole asset management aspect of the systematic well management plan is that we really wanted to manage things and really reduce it. I mean, we're going to have to spend some money on maintenance, and well rehabilitation is part of that maintenance, but it's going to last. It's going to have the well last the longest time, and really, if you add up all the costs at the end of that of the life of that well, it's going to give us the cheapest possible well. So really, well rehabilitation is an investment in that well, in that asset that you have. So it's part of your asset management plan. And I don't know why it is that wells don't oftentimes end up being considered in the same under the same umbrella as asset management of everything else in a water district, but a lot of times they aren't, and they're just a hole in the ground that keeps pumping water until they don't. So really, what like I said at the beginning, this is part of an asset management plan and something that you really want to manage start to finish, and that's part of your owner's manual, the OWPPP. Or PP, OWPP. Let me get it right. That's one of the things about doing live is you get every hiccup and glitch, and it's all caught there. So anyway, plan and budget. And well rehabilitation is important. It should, if done at the right time, it should allow you to restore your well capacity back to nearly what it was or completely what it was at the beginning if you've been doing these things on a regular cycle or as indicated by the well health check process. Okay, now we go to the optimal well performance plan. So, like I say, a lot of times we're not involved in a lot of these wells at the very beginning. So we haven't developed the owner's manual or the OWPP at the very beginning. So what we do is we come in the beginning. A lot of times we're brought in at stage 5 here. So we're going in and doing the well health check and getting involved in diagnostics and rehab. So steps 5 through 7. Now, once you've done that well rehabilitation, that is now your operational plan moving forward is to, if you don't have one already, developing your optimal well performance plan, and that guides you going forward. If you didn't have the owner's manual at the beginning, now is the time to develop one. You get everything back to as good as it can be, and now what is our operational plan moving forward? And that's going to be things like doing well health check on a regular basis, doing our well videos when we need to, the monitoring we need to do to determine what's going on in our well. And when I talk about monitoring, we look at, during the well health check process, a different set of parameters that may overlap with your water quality testing, but a lot of times they're going to be different and more diagnostic to the condition of the well rather than the water quality. Ultimately, it'll affect water quality, but it's not things that may necessarily be regulated by the EPA. So when I talk monitoring, I'm talking about monitoring not only for your water quality, but for those parameters that are going to be indicative of plugging and degradation of the well. So that's the monitoring there. This should include some estimate on your well rehab schedule. That's going to allow you to guide you going forward on that, and also allow you to plan and budget, which I think is important. And for maintenance, which we'll talk about in the next step here, is it what are you going to do to maintain that well? And that includes pump maintenance as well. We're going to want to bring people in and look at the pump check. We'll talk about that a little bit too here in the next step, and go from there. So basically, it serves the same function now as it did if you did one at the beginning. It's an owner's manual, but at this point, we've maybe got a few we've got a well rehabilitation under our belt, so we can fine tune that OWPP and tweak it and move it forward. So make sure it's not just written down somewhere, but it's in on a computer, so you can modify it and print up the new plan to have in the office and update your owner's manual, I guess, based on the new information. So that's going to be something that you shouldn't just tuck away either. It should be something you look at regularly, because in most small water districts, especially, people can come and go, and really it's something when somebody new comes in, they should look at the OWPP, the owner's manual for the well, and they should understand that, and they should operate according to that. So that's really meant to be a document that's used on a regular basis. So put it in a 3-ring binder, print it out, put it in a 3-ring binder, have page protectors on the pages, because it may get used a lot. So that would be my hope anyway, and that's really going to be your guidance on the well. Okay, annual maintenance. This is going to be something you're going to do on a annual basis, or maybe a semi-annual basis. You're going to have it's going to be part of your OWPP, is we're going to go in and we're going to maintain that well. We're going to look at things. So that may include doing a well health check. And you can see my dashed line here connecting back to the well health check. So I usually recommend doing a well health check on a annual basis, so we can track things, because in a lot of cases, especially in the cases of bacterial issues, it's not so much the total or the absolute number there, but it's the trends. If your bacterial load for in a well is increasing, for instance, that's not a good sign. I mean, there's certain absolute numbers where it becomes problematic, but a health issue. But really, if your numbers on your total bacterial load keep creeping up, or your total anaerobic bacteria, even more importantly, are creeping up as a percentage of total bacteria, now you got some issues. So you really want to track these things over time and look at that on an annual basis and plot them up, put them in a spreadsheet, chart them out. I'm a geologist. I like pictures. I like graphs. And so to me, it's easier to look at a graph, and you can get as fancy as you want. You can color code these things up, so when they fall within a certain danger zone, you can have them turn to yellow or red and give you heads up on that. So there's fancy ways of doing it, but this data is meant to be used, not just stuck in a file somewhere. And we see so much with small water districts especially, but any type of water district really is, people look at the data, they throw it in a file and never look at it again. And that's a waste of money. It's a waste of that data, because that data can be diagnostic, and it really can when it's used as part of a bigger program here and ties back into your annual maintenance, it's valuable information. So don't just look at it and throw it in a file. Really plot it up and put it on a chart and track that stuff. And so that's part of the annual maintenance, I call it, is do your well health check, plot that stuff up, see where you're at, look at the trends. Is there any trends that maybe you're okay now, but any trends you really need to keep an eye on? Maybe some parameters you need to go back in there and do semi-annually, twice a year to really look and see where you're at. So this allows you to give a little bit of a course correction here. If your well has been, if you've cleaned all the biomass out of your well and knocked it back pretty good, superchlorination once a year or twice a year can really help keep that bacteria from coming back. It won't totally stop it, but it can slow down the process. And Superchlorination does not work well as a primary method for cleaning the bacteria out of a well if you have a heavy biomass infestation, but running superchlorination, in my opinion, on an annual basis can at least help the bacteria from coming back as rapidly. So it'll slow things down and may spread out the time between well rehabilitation and save you some dollars and allow you to stretch that out a little bit. So doing your pump check, pump efficiencies are good. Doing your wire to water calculations are good at this point in time. So you're going to want to. There's a number of outfits that do it. Pump Check down in Southern California is a great outfit. We like them. If you're in the Southern California Edison area in Southern California, then they will do these things for you as well. So really getting your pump check can avoid problems too. And it's keeping everything running at tipped up shape. So, and it also, when you're doing regular pump checks, it also eliminates the pump as a source of your problem. So it helps you to pinpoint things a little easier. If you know your pump is in good shape, but you're still experiencing a decline in production, then you can start looking elsewhere because you know it's not the pump. If you've not been looking at your pump, you don't know what your pump efficiencies are, then it's really a matter of going in and really looking at what the other causes are, because you know it's not the pump because you've been maintaining the pump. Also, something that can help. It's not any substitute for well rehabilitation, but rawhiding your pump a couple times a year, and that's really just turning your pump on and off, and leaving it off for an interval, turning it on for an interval, turning it off for an interval, and what happens over time, especially silt and clay, will cause plugging in the gravel pack and in the aquifer. So by getting a little bit of flushing action by turning the pump on and off can get a little bit of a poor man's surge block going there, and it can help a little bit, because that one-way flow of water to the well over time is going to create sand bridges. It's going to create little zones of clay and silt accumulating in the pores that are going to block the flow and reduce well efficiency and ultimately production capacity of the well. So just by rawhiding the pumps a few times a year, that creates a little bit of a flushing action. Like I say, it's not the same as doing a surge block or a swab during well rehabilitation, but it's just something little that's easy to do, and do it for a day, and it can help. So now the last thing here I have on my list is a little bit controversy. There's people out there that recommend a light dose of well rehab chemicals, circulate them with a pump once a year or so, maybe go a tenth or a quarter of your normal dose and circulate those around. It's a little bit controversial because in a true well maintenance, you're going to be using a swab or a surge block to take the full strength chemicals and surge them back into the formation in the gravel pack to clean things out. A pump just isn't going to get those out very far. So and a pump, contrary to some people's belief, a pump is basically just going to affect the area around the intake of the pump, and so you're gonna, once you get away from the pump, you're going to have dead zones in the well that things aren't going to circulate. So it may help. It may not. I'm kind of on the fence about how much it really helps, but there's some people that swear by it. So I just throw it up here for the sake of completeness, and it's not going to hurt anything, that's for sure. But just don't, if you do it, understand what your costs are, and understand that it's not going to be a substitute for full well rehabilitation. There's just no way you can have the maximum effectiveness of these chemicals without getting them out past the well. I mean, we can clean up the inside of the well and make it look all nice and spiffy, but most of the action in reality is going to be outside the well from the screen through the gravel pack out into the formation, and that's really what you got to clean. And a light dose of well rehab chemicals circulated with the pump just is not going to substitute for well rehab. So it's not going to hurt anything. It may help a little bit, but so I throw it up here for the sake of completeness. Okay, so at some point you're going to get down to the end of the life of the well. I mean, the well is just you got patches on patches. The well is failing. The screens are corroded down. You got sanding problems. The seal is damaged, and so you just need to call it quits on this well and replace it. So we try to squeeze the life we can out of the wells, but at some point they're going to have a finite life to them. So we got to get down to the end of life, and that's our stage 10 because it's really something that we need to look at, and it should be a planned event. Like I say, it's something that we want to plan for so that we can budget for it. Like I say, in a municipal setting, even for small water districts, a new well can be anywhere from $250,000 up to $1.5 million for $2 million. So that's really a capital expense that needs to be budgeted for. So if we've been doing everything else, we should have a good handle on when our well end of life is, and we can plan for it. So that's it. And so we don't want to just walk away from that. That requires proper well destruction, which is a whole art in and of itself. But a well that remains open is really a danger, because that's a pathway for contamination to get into the aquifer as the wells sit there and deteriorate over time. It's going to the seal may fail, and you may start getting surface water flowing down to the aquifer and contaminating the aquifer with nitrates, for instance. So an open well that's not maintained or is not being used should be properly destroyed. And a few weeks ago, we had Tyler McMillan of McMillan Well Service on, and he talked about using explosive destruction of wells. That, in my mind, is really, we like Tyler, and he does great work. That, in my mind, is really the best way to seal a well. It's fast, it's efficient, and it's really the most sure way to destroy the well. So we recommend that method. There's other methods out there, drilling things out, pulling the casing, pressure grouting, but the explosive destruction really is the most sure way to go. So that's what I typically recommend, if at all possible, for proper destruction of a well after its end of life. And then really what we could do on this chart is we could really have an arrow that goes back to the beginning, because at the time that we're down to well end of life, we should have already planned out and be starting the process of well location and design of a new well. So the time that you destroy this well that's at end of life, you should really have a new well that's ready to come online and keep your production capacity up on a system-wide basis. So that's it. That's kind of a quick overview of the whole systematic well management process, and it's really something that we employ. If we're lucky enough to be involved from the very beginning, it's certainly a long-term process. But really, the key to it all is that owner's manual, the optimal well performance plan, and the well health check process. And I really think those are things that the OWPP is kind of your guiding document that allows you to manage that well properly. The well health check process really allows you to get an annual snapshot of the health of that well and alerts you to any problems that are coming up. So I'm a big fan of that. We're doing a webinar in a couple weeks on the well health check process. So you should see that on LinkedIn and elsewhere. I'll have some posts up on how you can register for that. If you're interested in that process, we go through it in a lot more detail, obviously, and dive in and tell you how to do that and go from there. So anyway, that's it for the presentation for today. Anybody that's watching out there, you probably already found us on the Groundwater Guy YouTube channel. Here's the URL, but we stream live into the Groundwater Guy YouTube channel. All our videos of past shows are up there. Then I pop in there to do some live streams or some videos on specific topics. So video shorts, I call them, and those are all up there on our YouTube channel. We're also looking at setting up duplicating the channel somewhere, because YouTube can be a little squirrely sometimes, and they tend to throw a lot of advertisement and things and makes it unwatchable. So I'm trying to set that up elsewhere where we don't have to deal with that issue. But for now, everything's at the Groundwater Guy YouTube channel. That'll stay there even if I set up a separate channel somewhere else. We'll just duplicate that and mirror that and have the videos there. But all our videos are there. We got some interesting past ones, like the one I mentioned that we did with Tyler McMillan talking about well destruction, explosive well destruction. He does a great job. So we had a great conversation there, and we'll have more to come. We're doing this every week. Okay, we also have a Facebook group, Groundwater Talk Live. We live stream into there. I'm not on Facebook a lot, but I know some people are, so we just set that up, and so you can go to the Facebook group, look for Groundwater Talk Live. There's the URL if you're into long cryptic numbers, but you can search for us at Groundwater Talk Live if you want to view it there. If Facebook is more your thing, then we're there for you there too. So. If you want to be a guest, if you got a great story, if you got anything that has to do with wells, groundwater, water systems in general, asset management, we would love to have you on the show. Here is the link or you can get a hold of me and I can give you the link. Here's the link to book it. I got a page up there that you can just find a time. We broadcast every Thursday, 9 a.m. Pacific time, 11 a.m. Central time, and so you can book there, and we'll set it up, and we'll talk to you, and we'll let you know how it goes, and coming on live is I just guide you through. So some people really worry about coming on live, but you don't have to worry about it. It's an easy process. Everybody that's been on has enjoyed it, and I try my best to make it a relaxing experience and enjoyable. So we'll ask some questions and get some good information, because really it's all about sharing information with the groundwater community out there. So if you got some great information to share, then yeah, book and come on and we'll get it out there. So lastly, almost lastly, you can get a hold of me on LinkedIn. Here's my LinkedIn address, so you can look me up there. I get on and I check LinkedIn regularly. We are live streaming into LinkedIn as well. I'm still getting used to that, so I'm not sure how well it's coming out on LinkedIn. I've done a few already, so you can look for us there. I'm still trying to figure out how to get the comments and stuff during real time. So I'm still figuring that out. But that's the best place to get a hold of me. My email is up there too. So if you want to talk to me about anything, you're more than welcome to get a hold of me on LinkedIn. If you want to connect, I'm always interested in talking to water folks. So. And lastly, we're always interested if you leave your comments. If you, I haven't been monitoring comments today, so I'm sorry on that. But if you're watching the video of this, the replay, then feel free to post your comments, questions, suggestions below, and I get on there. I look at those, and I'm more than happy to get back with you. And who knows, you might have the basis for a future show or a topic we can cover. So I'm always interested in getting your ideas and your comments and suggestions. So do that. Be gentle. I'm I'm not a TV host, but I'm just a hydrogeologist going live and chatting at you. But But quite frankly, just let me know what you think. So, hey everybody, thanks so much for watching. I really appreciate your logging on and checking this out. If you're watching it in replay, I appreciate that. Leave your comments, and we will see you